Welcome to our second session on how to perform a science project using the scientific method. In our first edition, we looked at how do you plan a project, and in this one we're going to look at how do you perform a scientific project. As a quick review, in our planning session, we first had to ask a question: what is the effect of the independent variable on the dependent variable? And then create our hypothesis, a prediction of the possible outcome. So in this session, we're going to look at which materials to use, which procedures to use, and how to collect your results. While performing our project, observing safety rules is extremely important, and accurate record keeping. Let's start with safety. The safety rules are very important while performing your experiment. Don't play the mad scientist. Always follow the instructions. Also make sure that you know where all the necessary safety equipment is, such as fire hoses and washing bin for your eyes, etc. Clearly label all the chemicals that you are using so that other people will know what is in your glass tubes. Dispose of all chemical waste according to the correct guidelines. And for your own protection, always wear safety gear such as a lab coat, safety goggles, and gloves. Accurate record keeping, use a lab notebook. One of the purposes of your notebook is to let other people get a clear impression of what the work is that you are doing. On the front cover of the notebook, you should have a description of what is inside of the notebook. Also, the first and last dates of entry should be written on the front cover. On the first page, create a table of contents where you clearly notate which experiments you have done and on which pages they can be found. At the top of each page, write the date as well as the title of the experiment. If this is a continuation of a previous experiment, write there continued from page number and indicate which page number. Before starting an experiment or a protocol, write 2 or 3 sentences on what it is you're trying to perform as well as why. Never use whiteout on your mistakes. Rather, draw a line through it and clearly indicate that it has been cancelled, and do the corrections next to it or underneath it. What must be found inside of the notebook is very, very important. There should be a detailed account of every planned and executed experiment, with as much detail as you possibly can give. Dates must be in with every entry, protocols that were used, reagents that were used, the lot numbers of each of the reagents. Where appropriate, try to add sketches and descriptions. Also explanations of any significance of experiments or any results that were obtained and conclusions of the experiments. Details of each experiment, and add some personal comments like, oh, this finally worked, or wow, this was a big failure. Photographs is very important, or computer-generated data if you have printouts. However, if the data is too big, you will have to keep it in a separate file with a clearly marked record of where this information can be found. The lab notebook is used during lab discussions and should be completed during your practical tasks and not afterwards, so any mistakes can be eliminated and you don't forget what is happening. At the bottom of the page, include your signature and the date. Remember how in the previous session we talked about the 4-question strategy? Well, here we're going to look at what action is observed when studying and how do I measure whatever it is that I'm observing. So the apparatus and the variables becomes extremely important. Making quantitative and qualitative observations and then completing tables so that you can actually draw graphs from them becomes a priority here. A variable is any factor, trait or condition that can exist in differing amounts or types. The best variables to observe would be those that can be measured with an apparatus. The first important step is to know which apparatus you are going to use and which scale you are going to use. For example, there are 3 temperature scales in use today: Fahrenheit, Celsius, and Kelvin. Which one would work best for your experiment? A photometer is an instrument that measures the strength of electromagnetic radiation. It starts in the range of ultraviolet through the visible spectrum into the infrared side. A device to measure relative humidity is called a hygrometer. Some variables are visible and others are not, and some environmental factors need to use chemical tests. Anemometers measure wind speed, and wind vanes measures wind direction. Atmospheric pressure is commonly measured with a barometer. True altitude is the actual elevation above the mean sea level. It can be measured using a radar altimeter. Qualitative observations is the research process of using subjective methodologies to gather information or data. Qualitative observation deals with the 5 major sensory organs and their functions like sight, smell, touch, taste, and hearing. It doesn't involve the measurements or numbers, but instead relies on characteristics. Quantitative observations is an objective method of data analysis that measures research variables using numerical and statistical parameters. Measurements, or measuring, is the act of assigning a specific value to a physical variable. Measurements is an extension of our senses. In scientific and engineering projects, the selection of equipment, techniques, and interpretation is extremely important. The metric system is an international system of units. Most countries in the world uses the metric system, which includes measuring units of meters and grams. In this system, each of the fundamental dimensions of nature is expressed by a single base unit of measurement. These measurements must be recorded in a table of results for comparison, from where specific types of graphs will be drawn that can interpret the information in specific ways. This is then part of one of our next sessions because it's quite a complicated process in itself. Once you have your graphs, you can start drawing your conclusions, which will then also be discussed in our next edition. So far we have learned how to plan our experiment and how to perform our experiment. In the next one, we'll see how to present this experiment. Please like, share, and subscribe so that you can also learn how to do a better science fair project.